Good evening everyone. My name is Arpan Kamru Shatangaira, 17 BC 1332. Today we'll have a look about a comparison of SQL and non-SQL databases. My research paper is based on the survey of SQL and non-SQL databases, which is the difference between a non-SQL and SQL database and how they work. We'll see this in this video. So let's move ahead. So NoSQL database, either NoSQL or not only SQL, are currently a hot topic in some parts of computing. In fact, one website lists over 100 of different non-SQL databases. This presentation reviews the features common to the non-SQL databases and compares those features to the features of capabilities of SQL databases. Did you get it? Topics that will cover in SQL databases and non-SQL databases. SQL standard, characters and examples. Same with the non-SQL database examples. So standard SQL, as we all know about that, the following is a short incomplete history of the standards. 1987 initial, 1989 referential, 1992 SQL2, 2003 we get the SQL XML codes, and now we are using the stable time period tables and all that. So characteristic data stored in columns and tables. That means you can create a table, you can store the values in it, you can add primary key, you can add constraints such as primary key, foreign key. You can add check constraints, you can set a value, you can delete a column, you can update, you can alter the table, you can do various things. You can also use the joins, then you can use that PLSQL, that means a programming language for SQL. That means you can program your SQL using a programming language. You can insert the values in your SQL, you can delete the values, you can also add triggers and cursors. Cursors basically points to a specific column of an SQL, and triggers will definitely give you a trigger when you do something wrong, or when you are about to do, when there should be a warning, something like that. We'll see about that. There's relationships represented by the data. That means a primary key, foreign key relationships, joint relationships and all that. Data manipulation languages, as I told you. Data definition language means primary key and foreign key has been defined and all that. Text is data types has been defined. Transactions means joints and all that, and abstractions from physical layer. SQL physical layer abstraction. Applications specify what, not how. Query optimization engine. Physical layer can change without modifying applications. Create indexes to support queries in memory databases. Data manipulation language, DML. Data manipulated with select, insert, update and delete. For example, select table name, select column name. You can write a table name where you have to write a condition. You can also do data aggregation, compound statements, functions and procedure. That, as I told you, PLSQL gives you function and procedure, triggers, explicit transition, that means triggers, cursors. You can do various things using an SQL. Definition language, schema defined as create table, as I told you. Constraints defined to primary key, foreign key, check, delete, like that. You have various constraints. Trigger, as I told you, to respond the insert, update and delete queries. Stored modules, you can alter the table, you can drop the table, you can also add the security and access the control. Transactions, atomic, as you all know that it's based on ACID properties. Atom, all the work in a transaction completes, commit, or none of its completes. Consistent, a transaction transforms the database from one consistent state to another consistent state. Consistency is defined in terms of constraint. Isolated, the results of any changes made during a transaction are not visible until a transaction has been completed. Durable, as we all know, the results of the committed transactions survive failures. Database examples are IBM, Oracle, Microsoft SQL Server, open sources MySQL increases. Significant portion of world's economy use SQL databases. Now let's move ahead to non-SQL databases, which is not familiar among our users. So let's do it. Next generation database is most addressing some of the points, being non-relational, distributed, open source, horizontal, scalable. The original has been modern web scale databases. Movement began in 2009, as we all know. Basically, non-SQL is distribution type of databases, multimedia databases. Like if you want to store images, files, movies and all that, you have to store in a database with records. If for example, if you want to maintain a criminal record, you require the name, persons, all the data, and you also require image, because without an image a person cannot be identified. So that goes into multimedia database. And you can distributed databases are like that is used by various databases are stored in various users. Means all the control is not accessed by the one user, it's distributed among the control. So user can access it but not make any changes to it, like that. Products and project, Cassandra, CouchDB, Hadoop, as you know, StupidDB, etc. The projects. Distinguishing characteristics are large data volumes. Google is big data. Scalable replication and distribution, potentially thousands of machines, potentially distributed around the world. Queries need to return answers quickly. mostly query few updates, asynchronous inserts and updates, schemaless, Azure transaction properties are not needed, base, cap theorem, open source available. Acronym contrived to the opposite of ACID, basically available, soft state, eventually consistent. Characteristics weak consistency, available first, best effort, approximate answers, aggressive, simple and faster. The distributed systems cannot support only two of the following criteria: consistency, availability and partition tolerance. Consistency, all the nodes of the same data at the same time. Client perceives that a set of operations occurred at all once. More like atomic and acid transaction properties. Node failures do not prevent survivors from continuing to operate. The system continues to operate despite arbitrary message loss. Operations will complete even if individual components are unavailable. Column store, document store, key value store, hash tables of case, etc. are the database types. Other non-SQL XML, graph, Cadassi, object-oriented database, etc. Column store, as you can see. Components are more efficient than row or document store. Multiple row record documents are inserted in the same time, so update of the column can be aggregated. Retrievals access only some of the columns in a row record document. Then an example of that non-SQL databases. So you declare an ID variable like that, type, author, title, body, NoSQL databases, and you can just close the braces. As you know, unique identifier, revision number, types, etc. Hash tables of key values stored with the keys, fast access to small data volumes, etc. Let's move ahead. MapReduce, technique for indexing and searching large data volumes. Two phases: map and reduce. Map, extract sets of key values from pairs from underlying data, potentially in parallel or multiple machines. Reduce, merge and sort set of key value pairs. Results may be useful for other researchers. So as we know, let's move ahead. MapReduce techniques differ across products implemented by applications. MapReduce patent. A large-scale data processing system and method includes one or more application-independent map models configured to read input data and to apply at least one application-specific map operation to the input data to produce intermediate data values, wherein the map operation is automatically parallelized across multiple processes in the parallel processing environment. A plurality of intermediate data structures are used to store the intermediate data values. One or more application-independent reduce modules are configured to retrieve the intermediate data values and to apply at least one application-specific reduce operation to the intermediate data values to provide output data. Storing and modifying data, syntax varies, HTML, JavaScript, etc. Asynchronous insert and updates do not wait and for confirmations. Retrieving data, syntax varies. As I told you, the syntax also always the first important point you keep to know is that always the syntax varies with the different types of concepts, different types of problem and different types of set of application you are learning. Application specifies retrieval part, no query optimization, quick answer is important, maybe not a single right answer. Open source, small upfront software cost suitable for large scale distributions for NoSQL summary. So as we know, overhead of ACID transaction is opposite of ACID, so we call it as a base transactions. Complexity of SQL, burden of front schema design. As we all know that we have seen that its burden of front schema design, declaration query expression is quite different. I will not say quite different. It's completely different from the SQL, and yes, it is different. Programmer responsible for step-by-step procedural languages and navigating examples. Wherein on SQL database are predefined schema, standard definition, and interference language, tight consistency, well-defined schema. No predefined schema, pre-word definition, and interference, and getting an answer quickly is more important than getting a correct answer. So basically, I make a point here that SQL databases are used for confined, true, correct, and predefined and well-defined answers, well-defined schemas. Whereas NoSQL databases are used where the large number of data are required. Fast answer is very important, not a correct answer. Means like if you search anything on Google, a fast answer is more important than a correct answer. Maybe if you search for a lime juice, if the first answer comes as a juice, it's more important whether it is lime or not. but if you search for limes and it takes a 1 minute, it's not very good effort. So NoSQL database can be done, but if there is a bank ID transaction where you want to be accurate, where you want to 100% authenticate, then it's SQL database. So each database has its own advantage and disadvantages. Each has its use and not function uses. Each can be used in various parts of applications, etc. etc. So how to write a CV as well. Thank you. It was fun. If you have any questions, let me know. I'll answer them. You can post them in the comment section. Please subscribe the channel or please hit a like button if you like the video. Thank you.